Hello, I welcome you all to this another interesting screencast. The problem reads, the lawn roller has a mass of 80 kg. If the arm BA is held at an angle of 30 degrees from the horizontal and the coefficient of rolling resistance for the roller is 25 millimeters, determine the force P needed to push the roller at constant speed. Determine the force P needed to push the roller at constant speed. Neglect friction developed at the axial, and assume that the resultant force P acting on the handle is applied along the arm BA. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, we are again dealing with rolling resistance, and we've been asked to determine the resultant force P. Just a recap of what rolling resistance is. So if we have a rolling body of mass M, of weight W, and imagine this is rolling at constant velocity, and we apply a force P to maintain the motion because this roller, so we apply a force P, and then let's say this rolling body is rigid, and then the surface on which it is rolling is less rigid. Surface is less rigid, or relatively, this rigidity is when we compare its rigidness is less rigid compared to the rolling body. So we have the deformation on the surface, and therefore we expect the normal force to be at an angle like so, but they are going to be concurrent. They are all going to be concurrent at the same point. Okay, there we go. So then we'll have an angle, theta, and then some distance from this point there, some horizontal distance we are calling A, and this is what we are terming as the coefficient of rolling resistance. So what is this rolling resistance? Rolling resistance itself, this is the opposing force a rolling body in motion experiences when it is in contact with the surface. So the rolling resistance is the opposing force that the rolling body experiences when it is in motion and it is in contact with the surface. So this normal force is retarding the motion of this rolling body. So to maintain this body at constant velocity, we need to apply a force P, because this rolling body will be experiencing this retarding force N, which will have components in the horizontal and in the vertical. Right. So this is what rolling resistance is all about. So and this is what we want to do right now. Let's redraw the free body diagram of the lawn roller, and then include all this information that we've just shared. So we have the lawn mower like this, and it has some weight, W, which we are going to calculate later on. And then at the axial here, along the arm AB, we have a force. We have a force P, okay, and it is at an angle with a horizontal. It is at an angle of 30 degrees. So this is going to have components. We'll have one component in this direction like this, and this is P cos 30, and then we'll have another one there. This one is going to be equal to P sine 30. The radius of this lawn roller or mower is 250 millimeters. And then we have a normal force at an angle. Let's say it is somewhere there. It is somewhere here. Okay, N, and is concurrent with all the other forces. And then let me remove this. I write it on the other side, 250 millimeters. Okay, and then we have, with the vertical, we have an angle there, theta, which is the angle of the rolling resistance. And then we have this horizontal distance that we are calling A, and it is equal to the rolling resistance, the coefficient of rolling resistance for the roller is 25, so this is 25 millimeters. Alright, so this is about it. So let's call this point here, this point here is our A. Okay, so what we are going to do now is to apply the equations of equilibrium so that we find what this P is. So let's go ahead to say summation of moments about point A equal to 0 and clockwise being our reference. What do we have? Okay, we have the following. We have minus which is plus. This one is causing minus, so minus P sine 30 times the lever arm, which is A. So I'll just put 25. It will cancel out with the others, so I'll just leave it 25 millimeters. And then I have P cos 30. This is a plus. P cos 30 times this distance here. Okay, since this distance, we need to calculate this distance here. Okay, and this distance is going to be equal to r cos theta. Okay, so we need to find what theta is. So theta, what is this theta? Theta is going to be equal to sine inverse of the opposite, which is 25, divided by hypotenuse, which is 250, right? Therefore, this theta is going to be equal to, this theta is equal to, what is it? Let's calculate it. 25 divided by 250. And sine inverse of that, we have a 5.7392, right? 25 divided by 250, sine inverse of that, 5.7392. Great. So this is going to be equal to, is equal to 250, this is equal to 250 cos 5.7392, right? Yes, so this is 250 cos 5.7392. All right. What else? So there we go. Of course, there we go. And then what else do we have? We have W. Almost forgot W minus W times. What is W equal to? W, we already know what it is. W is 80 times 9.81 times let me write it the other side, I don't have space, minus this 80 times 9.81 times 25 is equal to 0. So therefore, let's make P subject to a formula. If we made P subject to a formula, let's do it. Minus 25 sine 30 plus 250 cos 30 cos 5.7392. There we go. Then we have 80 by 9.81 by 25. All right, great. So we have, finally the solution is 96.1 96.69 if we rounded it off, right? And what are the units? The units are in newtons. Great. So this is about it. This is the value of P. This is the value of P that we need to be applied along the arm BA, so that we are able to push the roller at constant speed. I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.